When we think of honey production, this insect is the universal standard, the stinging honeybee, and we know exactly how they store their harvest. They build rigid, geometric grids of perfect hexagons made out of beeswax. But deep in the Malaysian tropics, there is a honey that breaks these rules. It's dark, highly liquid, and instead of being intensely sweet, it has a sharp, sour taste. It's an active, frothing liquid. This creates a strange paradox for people with diabetes. While standard honey typically causes blood sugar to spike, this specific liquid is sought after by patients who report a completely different effect on their glucose levels. The insect responsible for this liquid is a native species known as the Leba calilut. If you approach its nest, you'll find it lacks a primary weapon. It has no stinger. To understand how this bee creates such a distinct substance, we have to look past the honey itself and examine how the colony is built from the ground up. Let's start with the basic composition of a honeybee hive. A typical colony is built using about 90% beeswax, secreted from the bees' bodies, and only 10% propolis, a sticky plant resin. The calilut flips this ratio. They construct their world using 90% propolis and only 10% wax. Because they use so much propolis, the bees forage the jungle for building materials, harvesting raw, sticky tree sap directly from the bark. They deploy this resin to build a fortress. The entrance is unmistakable, a long, trumpet-shaped funnel sculpted from these gathered resins. Since they have no stingers, they use this sticky resin as a biological glue. It seals the hive against wind and water and acts as a physical barrier against predators like ants. Inside the hive, the architecture changes. Instead of hexagonal cells, the bees build kantum, dark, bulbous pots of propolis that look like organic stone. Substituting wax with tree resin changes the physical environment of the hive, creating the specific conditions required for the honey to ferment. When nectar is deposited into these resin-walled pots, a chemical process begins that you won't find in a standard beehive. The nectar sits inside the cantung for up to 45 days. Trapped inside the propolis chamber, the liquid ferments, which produces the active, natural bubbling and the completely unique signature sour taste. This fermentation changes the sugar profile of the nectar, breaking them down into highly digestible simple sugars. Because the fermentation process pre-digests the nectar, these simple sugars are absorbed easily, providing energy without the insulin spike. While it ferments, the propolis walls infuse the liquid with the natural defenses of the tree resin, adding antibacterial and anti-inflammatory properties. The bees go to great lengths to find these specific ingredients, flying up to 5 kilometers away from the nest. They forage for resins, pollen, and nectars from medicinal jungle plants, drawing the protective properties of the forest into their food supply. The result is a substance that acts as a fermented extract of the surrounding jungle ecosystem. Historically, harvesting this honey was a destructive process. To reach the cantung pots, humans had to chop down the tree trunks that housed the wild nests. Modern agriculture has found a way to mimic this environment. Farmers now transition wild colonies into sustainable, modular boxes. These boxes replicate the dark cavities found in trees, protecting the bees' propolis structures while allowing the honey to be harvested without destroying the hive. This creates a direct link between the honey and the health of the rainforest. The bees cannot produce these compounds without a diverse, intact ecosystem to provide the necessary resins. It's a specialized partnership. The calilut is adapted to extract the defenses of the Malaysian jungle, and those defenses happen to be uniquely suited to support the health of people living nearby. The calilut reminds us that effective defense doesn't always require a stinger, and the most valuable products of a forest are often found in its most unusual corners.